Good morning, students. In the previous class, we have introduced combination of error and to solve numerical using that concept. Today, we'll continue to the same topic. Here, we have to find error in division of physical quantities. Like again, if we are taking that quantity A as it is A plus minus del A, B that is B plus minus del B. So if there is an operation that Z equal to division of A and B. So in that particular case, if we have to find absolute error in Z, that is in the division operation. So it will be del Z upon Z. And it will be equal to again sum of relative error or fractional error in each of the individual quantity. So here, although this is the division operation, so correspondingly this relative error in the total operation, it will be equal to sum of relative error in individual quantities. So here you have to just learn the results either in division or in multiplication. Here you will take the sum of relative error in individual terms. Likewise in addition and subtraction, you have taken absolute error in the sum and difference as addition of absolute error or sum of absolute error in individual terms. So now how can you revise this result as the maximum fractional error in the quotient of two quantities is equal to sum of their individual fractional errors. So this will be the result. You have to learn this result. Now on this basis, to get more clarity, let me take one example. If voltage is given to be 100 plus minus 0.1 volt and current is given to be 10 plus minus 0.2 ampere. Find resistance corresponding to the given value of voltage and current. Now you are familiar the relation between voltage, current and resistance. V equal to IR. So resistance will be equal to V upon I. So first of all, as you have to find resistance with proper error limits. So here resistance will be, as voltage value is 100, current value is 10. So it will be 10 ohm. Now to find error limits, so we have to find, as this is the division of voltage and current, so you have to find fractional error or relative error in R. This will be equal to sum of relative error in voltage and current. Now here, as del V it is 0.1, voltage is 100 as per the statement, del I is 0.2 and current is 10. So now just the calculations is required. This is, you will take its LCM. It is 1 plus 20. It will be 21 by 1000. Let me check. 0.1 upon 100. This is 1 upon 1000 plus 0.2 upon 10. So it will be 2 upon 100. When you will take its LCM, it will be 1000. Here it is 1. And it will be 10 into 220. So it is 21 by 1000. Now, as del R upon R we have taken. Now, what will be the absolute error? You will multiply this R, cross multiply on the opposite side. Now, R here is 10 as from the calculations. So, here it will be, this is your 0.21 ohm. So, resistance with error limits, it is R plus minus del R, so it is 10 plus minus 0.21 this much ohm. So see in this question what we have taken, as this R is the ratio of voltage and current, so that's why to find absolute error in R we have no other way but instead we have to find only relative error in R. See in this question it has been asked that find resistance with error limits. Resistance with error limit, it should be in the questions. Now if we have to find, instead of it, if we have to find percentage error in resistance, then what we have to do in the same numerical? See, Now, here for the same statement, but the final result has been changed. Find percentage error in measurement of resistance, as resistance is V upon I. Now, del R upon R. Percentage error, it has been expressed in terms of relative error and then multiplied by 100. So, it will be the percentage error in resistance. So, what we require initially? We require relative error or fractional error in R first. So basic concept, we require this one. We have to find relative error in R. Then we will multiply it by 100 to get percentage error. So here del V upon V plus del I upon I into 100. See, in this case, when percentage error has been asked, then no need to find the resistance. No need to substitute value here. If resistance value has been asked, then only you have to solve it. So now substitute the value. Del V is 0.1 upon 100 plus 0.2 upon 10 into 100. So here again you will take its LCM. This is 2 upon 100. Step is almost in the similar way you will proceed. It is same LCM. 1 plus here it will be 20 into 100. This is 21 upon 1000 into 100. So it will come out to be 2.1%. So percentage error in the measurement of resistance, maximum or minimum, total plus minus sign has been taken. So total error in the measurement of resistance, it comes out to be plus minus 2.1%. So this can be one way to ask where division operation will be used. Now, after this, next is error in power of the quantity. How can we understand it? See, if you have any quantity that is depending on A, but A raised to the power n. So here also we have to use the concept of fractional error. You have to find fractional error in Z, but the rule will be slightly different. Here A raised to the power n. So when you have to find relative error in that case, what you have to do, this power will come in multiplication. So n multiplied by del A upon A. This will be the rule which you have to learn. So what is the basic rule here? Fractional error in nth power of a quantity is n times the fractional error in the quantity. Here the quantity is in terms of power, but the fractional error in the quantity will be given by n times the fractional error in the term A, whatever term we are using it. So this will be the rule which you have to use. Let me take one particular example. This is a kind of numerical you can take. If z equal to A raised to the power p, b raised to the power q, and upon c raised to the power n. So you can see in this statement there is a combined effect. Here the power concept, A raised to the power p, b raised to the power q, again power concept, c raised to the power n, power concept. You can also see along with power operation there is multiplication. Here A and B terms are multiplied, and also the concept of division. So how to use when all the concepts are coming together? Now we have to apply all the formulas here. You can see as we have to calculate relative error in each of the operation. It will not make any difference, but the new concept will be that you will multiply it with, you have to use the concept of power also. So here what you have to do, find relative error in Z. So del Z upon Z, this will be equal to, here A raised to the power P. So this is a power P multiplied by relative error in A, plus Q into del B upon B, plus C raised to the power N. So N will come in the multiplication, del C upon C. So this will be the relative or fractional error in Z. Now after this you can see that here there is a point which can confuse you, that here is a division operation, divide by C. So don't get confused with it. Why? Because when it is in the division operation, we have never to use in the negative formula. We have never to use minus power for it. This is a assumption which we have to apply here. As c raised to the power n is in the denominator, you will simply use the concept of division operation and it will come as a plus n multiplier multiplied by the relative error in c. So in this way I have introduced all the formulas, all the rules for combination of error. Now after this we will do few numericals where we will use all these concepts. Now here we are taking one numerical if length, breadth of rectangle are given to be this 10.5 plus minus 0.2 centimeter and breadth is given to be 5.2 plus minus 0.1 centimeter. So calculate perimeter of this rectangle with error limits. Now see, as per the statement, length and breadth of rectangle are given. So what is the perimeter of rectangle? It is 2 into L plus B. So now length value has been given to be 10.5 plus 5.2. So when you will solve it, it will come out to be, this is your 15.7 and its value is 31.4 centimeter. Simple calculation in the maths you do. Now what you have to do, you have to find absolute error in it. So del P will be equal to, this is del L plus del B. Now twice this is in the formula. So here it will be, this is 0.2 plus 0.1. So it will be 2 into 0.3. It is 0.6 centimeter. So what will be the perimeter with error limits? So it will be 31.4 plus minus 0.6 centimeter. Perimeter having the dimension unit of length. So now you can see this is the case where here we will do all kind of numerical addition, multiplication, division, power form. So this is the concept based upon the sum of the quantities. Now next numerical. If error involved in measurement of mass and length of one side of a cube are given 4% and 3% respectively. Calculate the maximum permissible relative error in density. See here in this question, we have been asked the relative error in density, but mass and length, percentage variation in mass and length has been given. So density, it is mass per unit volume, and volume being the side of a cube is given. So volume of cube will be length cube. Now the formula will become this one. So now here you have to calculate permissible relative error in density. So first of all you have to take relative error in density. This is equal to sum of relative error of mass, and now this is L cube. Here power operation will be used along with, and this power, this will be in multiplication and tail L upon L. This is the main point. If it is clear, then no problem in the further solving of numerical concept, because it is only the calculation part left. So here what we have done, here two operations are required, as division operation as well as power operation. So due to the division operation, sum of relative error; due to power operation, 3 multiplied by relative error in length. Now here what has been given, as error involved in measurement of mass and length are in 4%. Basically what is given, del m upon m into 100. This is given to be 4%. And del L upon L into 100, it is given to be 3%. You can see here that percentage error in measurement of mass and length, although it is not mentioned directly in the statement, but by this 4% and 3%, it is clear that this is only the percentage error in measurement of mass and length. Now to solve it further, let me multiply both the sides by 100 to convert it into the same form. I am just on the right hand side multiplying 100 as a common. Now directly I can, or if you have just any confusion, you can take it in this manner also, or you can take it directly also. Now this value is given to be 4% plus 3 into 3%. So 4 plus 9, it is 13%. So this is a concept where you have obtained permissible relative error in density. See, as we have introduced this concept, basically when in the question it has been asked accuracy in measurement of the quantity, then we have only to find either relative or fractional error or percentage error. This concept will also be coming in the next few, just in the next numericals. Then it will be more clear. Now let me take another numerical problem. So here, error in measurement of radius of a sphere is 4%. What would be error in volume of sphere? Error in radius of sphere is given and you have to calculate error in volume of the sphere. So now we know volume of sphere is given by 4 by 3 pi r cube. Now we have to calculate error in volume of sphere. So here del V upon V will be, this is your 4 by 3 pi, this is unknown factor, this is constant which we will remove. So it will be del R upon R and the power is in the multiplication. But the error in radius is in percentage. So in the next step what will you do? This you will multiply it by 100. So 3 del R upon R into 100. You can take it as plus minus because in both ways it can be applied. Now radius, error in the radius measurement is 4%. So the final answer will be 12%. So simple numerical. Now next numerical. Here, if percentage error in measurement of A, B, C, D are 1%, 2%, this is 3% and 4% respectively. What will be the percentage error in X, where X is a physical quantity depending upon these 4 parameters as by this result. Here A raised to the power 1 by 3, B raised to the power 4, divide by C into D raised to the power 2 by 3. Now statement is this one, and error in percentage error in measurement of A is 1%, in B is 2%, similarly in C is 3% and in D is 4%. Now here you have to find percentage error in X. So apply the result del X upon X equal to, here A raised to the power 1 by 3, what should be? It should be 1 by 3 del A upon A plus B raised to the power 4, it will be 4 multiplied by del B upon B. Divide by C plus del C upon C plus D raised to the power 2 by 3. So it will be power 2 by 3 multiplied by relative error in D. Right? Now in the next step, because as the result you have to obtain in the form of percentage error, so multiply both sides by 100. So when you are multiplying by 100 for each individual term, what you are getting? Here you are multiplying each relative error by 100, or you can take this 100 as a common also, you can do in any manner. Now percentage error value you have to put 1 plus 4 into 2 plus this is 3 plus 2 by 3 into 4. So it is 1 by 3 plus 8 plus 3 plus 8 by 3. So now if you will solve it taking these together, this is 8 plus 3 11 plus 8 plus 1 9 upon 3. You can take its LCM, so it is 11 plus 3, this is 14%. So percentage error in the measurement of X comes out to be 14%. Now see here, in the similar way, there is one more numerical. Time taken by a body is 20 plus minus 0.2 seconds in undergoing a displacement of 200 plus minus 5 meter. Calculate velocity with error limit. See, velocity is displacement upon time. So this is the concept of division. So I am leaving this question for you as an exercise. You will do it as a homework. So because it is totally based upon the division. If you remember, just before it, I have done the concept of resistance is voltage per unit current. So in the same way, you have to calculate here velocity with error limits. So this will be as a homework for you people. Now coming to the next numerical. Now see, in the next numerical, some different concept will be used utilizing all the results which we have learned today. So here, if two resistors of resistances R1, that is 4 plus minus 0.5 ohm, and R2 equal to 16 plus minus 0.5 ohm. These are connected in series and in parallel. Two arrangements are there. First they are connected in series, then in parallel. So find the equivalent resistance in each case with limits of percentage error. So now, as the resistance are given, you have to find equivalent for series and parallel combinations with the particular limits of percentage error. So how to proceed it? Now, first of all, when we are taking for series combination, for series combination, you have already done this concept. This is R1 plus R2. Let me represent it by RS or R, any symbol we can use. Then R1 plus R2 will be 4 plus 16. It is 20 ohm. Then the error limits we have to obtain for series combination also. So del RS, it will be equal to, we can take it plus minus, just indicating the same concept. Here, so relative, this absolute error in series combination of resistance is sum of absolute error in each of the individual resistance. So it will be, here it will be 0.5 plus 0.5. This will be equal to 1. This is equal to 1 ohm. Because we are taking resistance, so it is 1 ohm. So RS with error limits is, this is your 20 plus minus 1 ohm. See, here in the statement we have been asked to find resistance with limit of percentage error. This is in terms of absolute error. So what next step you have to do? As you have to find percentage error in R. See, in this result, in RS we have to find percentage error. So absolute error in RS is 1. So it will be 1 divided by 20. Why we are doing this? Because this is del R upon R into 100. So 1 by 20 into 100. So it is 5%. So now with error limits, RS can be written as 20 plus minus 5%. This much variation in the resistance, 5%. Now the next point that is very important, in parallel combination you will learn new result. You have to learn the result, as when you are taking parallel combination. In parallel combination of resistance is obtained that 1 by R base 1 by R1 plus 1 by R2. So when you will solve it, Rp will come out to be R1, R2 when you will take its LCM and solve in general form. Now R1 is given to be 4, R2 is 16, R1 plus R2 is, this is 4 into 16 by 20. So it will be 64 by 20. So it is 3.2 ohm. This is the equivalent resistance. Now, as we have to obtain error in parallel combination, so you have to learn one result. This is a result that is also given in numericals of NCERT, solved examples of NCERT. What is the result? As 1 by Rp equal to 1 by R1 plus 1 by R2. So here del Rp upon Rp square is equal to del R1, because in this here R1 is in this part, first part, so del R1 upon R1 square plus del R2 upon R2 square. Although we can derive this particular result by the concept of differentiation, but here we are not doing that because that is a new operation. We have to just learn this formula. So you have to rather learn this formula and just you have to substitute the values for solving it. Now, as you have to calculate del RP, so del RP will be equal to RP square del R1 upon R1 square plus del R2 upon R2 square. Now RP we have obtained, that is 3.2 square. Del R1, absolute error in 1 is 0.5 and R1 is 4, that is 4 square. Similarly, absolute error in in R2 is also 0.5 and the value is 16, that is 16 square. So now when you will solve this, what you will get, this is 3.2 square. Here you can see this 0.5 is common. Now it is the calculation part. It's up to you how you will do it. So it is 1 by 16 plus 1 by 256. Now it is 3.2 square. When you will do it is 10.24 into 5 by 10 into, when you will take its LCM, this is 16 plus 1. So after this, when you are doing 10.24 5 upon 10, this is 17 upon 256, and when you will solve it completely, then the answer will come out to be 0.34 ohm. So by this way you have calculated the absolute error in parallel combination of resistance. So RP plus minus del RP, it comes out to be 3.2 plus minus 0.34 ohm. But we have to find percentage error in the combination. So percentage error, that is del RP upon RP into 100. It comes out to be here. This is your 0.34 upon 3.2 into 100. So when you will solve it, it will come out to be 10.625. You can round it off, you can write it 10.6%. So this will be the percentage error in parallel combination. So this will be the result for parallel combination. See, I am just revising this concept because here is a new concept introduced in the parallel combination. As in the parallel combination, the standard result you are familiar with. Simply by solving it, you are getting the result and you are calculating resistance in parallel combination. But now, when you have to find absolute error, in that particular case, what we are doing, we are learning this result. And then by learning this result, we are substituting the values. By substituting the values and further doing all the calculation part, you are getting this. Although in this question percentage error in series and parallel combination has been asked, so you will do the percentage error part like this. See, this is a particular way. Actually, this is the way, this is more appropriate where we have learned one particular unknown result in terms of one del RP upon RP square equal to del R1 upon R1 square plus del R2 upon R2 square. But there is one alternate method also for this parallel combination of resistance. I am explaining it, although when you will do by this method, the result will also be correct, but there will be variation in the final results. So this you have to just understand. In this result which I am following at this time and the previous which I have explained you, there will be variation in the result. How? Let me see. As RP is R1 R2 upon R1 plus R2. Now if you see this result, this is the product of R1 R2 and this is the sum of R1 and R2 and this is the division operation. It means addition, multiplication and division. All three operations will be used here. And R1 R2 upon RS, because R1 plus R2 we have represented it by RS. Now apply the error combination result. First of all, we will find relative error in RP. So it is del R1 upon R1 plus del R2 upon R2 plus del RS upon RS. See, the calculation will be simple. Now del R1, that is del R1 upon R1, and here this is del RS is del R1 plus del R2 upon R1 plus R2. Now R1, that is the absolute error in R1 is 0.5 and the main value of R1 is 4. Absolute error in R2 is 0.5 and the value is 16. And this is 0.5 plus 0.5, this is 1 upon the sum of R1 and R2 is 20. Now, what you will do in the next step, you will simply solve it. 5 by 40 plus 5 by 160 plus 1 by 20. Now the LCM is 160. So it is 4 into 520. It is plus 5 plus 8. Then it will be 33 by 160. So it is del RP upon RP. Now here RP we have obtained from the previous calculation, that was your 3.2. So now if you have to calculate del RP, it is RP into 33 upon 160, and RP from the calculation, when you will substitute the value, it comes out to be 3.2 as I have explained it earlier. So it is, you will get it as, this is 3.2 into 33 by 160. Just simplify it. Then what you are getting here, this is your 66 by 100, this is 0.66. So here this del RP comes out to be 0.66. Here in the previous case it was 0.34. Now percentage error in RP is, so it will be del RP upon RP into 100. So it will be 0.66 upon 3.2 into 100. When you will solve, it will approximately come out to be 20.6%. So this is the difference. See the method, this is you are familiar with. Here no new result has to be learned by you. So here the result is this one, in multiplication, division and addition result you are applying here in the combined form. So here when we are applying relative error, this is del R1 upon R1 plus del R2 upon R2, being the product of R1 and R2. And in the denominator, as this is R1 plus R2 as RS, so plus del RS upon RS. Now just next step we are doing, this is simply substituting the values and doing the calculation part. But when we are doing the calculation part, we are finding the results are not similar to that in the formula which we have done earlier. So you can choose any method which you found to be comfortable. But if in the statement, if it has been asked that you have to do the numerical by this formula, if it is specified in the statement that you have to find the error in the parallel combination only by this formula, then you have to use this result only. Then you cannot do by the other method. Just be careful about it. If no method has been specified, then you can choose any of the two methods. But if it is specified by the result which I have shown you, then you have to do only by that method. So these are numericals. We have maximum numericals I have covered on the combination of error. So give it a written practice and solve more numericals. So in the next class we will take one or two more numerical on the same concept. Until then, just revise all the concepts, keep enjoying and studying. So have a nice day.